Full. I think we'll start a minute early. Do you think that's okay? I think it's okay. So two apologies. First apology is there are people standing at the back of the room. Obviously with events of this type where they are free events with open registration, we have to overbook the events in order to make efficient use of the space. And we've got a higher than normal turnout today or the lower than normal dropout rate, depending on how you look at it. We have data that we use, believe it or not, to figure out how much we should overbook events like this. And you guys are just too keen, or you guys and ladies are just too keen, so we are slightly fuller today than we anticipate. And also, it's also, of course, difficult for us to balance across the tracks. So we're obviously very full in this room right now. Last time I checked, there were a few seats left in the AI and ML track. You can move around during the day if you get bored with standing or you want to go and see some content that's in another track. So don't feel obliged necessarily to stay in the same room all day. You don't have to do that. Second thing I'm going to apologise for is the individuals sitting at the far sides of this room. Because we're recording this session and we're going to be streaming it on our Twitch channel over the course of the next couple of days, I've been told that I have to stand in this sort of 10 to 12 foot area in the centre of the room here, which is not my normal way of doing things. So if you're at the edge of the room, hi, okay? I'm probably not going to be down there very much during the day because I have to talk to this camera so that we can share this content on our Twitch channel later in the week. Also mention on Twitch that if you want to catch up with any of the content from today that you don't see live, you can jump onto twitch.tv/AWS tomorrow or Friday, and we'll be vodcasting the other two tracks. So tomorrow we'll be vodcasting the containers track, and on Friday we'll be vodcasting this serverless track. So if you do want to go and watch something else, you'll be able to catch up on the content later in the week, okay? twitch.tv/AWS. And the last bit of housekeeping is, at the end of the day today, we're going to be hosting a happy hour and drinks reception in that networking area at the end of the venue. So if you want to hang around at the end of the day and have a drink with us and our partners, please do so. We've got some food and some soft drinks and beer and wine coming in later on today for you to enjoy. So please stick around at the end of the day for that as well. Okay, so let's kick off. Just to quickly introduce myself, my name's Ian Massingham. I'm responsible for developer relations or technical evangelism at AWS worldwide. You can probably tell I am from the UK. Still live in the UK, but have this worldwide responsibility at AWS. I also help run events like this, so the overall developer education content program that we have. So if you've got any feedback about the event, you can reach me here on Twitter, or you can email me. It's just ianm@amazon.com, Indigo Alpha November Mike at amazon.com. Happy to take your feedback. You'll also get a feedback survey after the event today, where we want to gather some feedback, comments from you about how we're doing with our event program. So please reply to that. We will also send out all of the slideware from today in the form of links to the content on SlideShare, where you'll be able to see and download all the materials from every track. So you can refrain from taking pictures of the slides if you are doing that just to get a record of what we're showing to you, because we're going to send that out. And we'll also include links there to videos of all the sessions as well that you'll be able to watch on the AWS YouTube. So as well as the vodcast, in a week or so, we'll have all of the content up available on YouTube for you to watch as well. So plenty of opportunities for you to revisit the content and catch up on anything that you've missed as well. Okay, so in this room, we're focusing on serverless today, not just AWS Lambda, which is what a lot of you will think about when we talk about serverless applications on AWS, but also the broader ecosystem of components that we have that can help architects create applications in this way and help developers build and deploy and operate applications where you don't have to worry quite so much about managing underlying infrastructure components. You can spend a lot more time on the higher value parts, the unique parts of the applications that you're building. That's what we think about when we talk about, actually what we think about when we talk about the AWS cloud more generally, and specifically what we think about when we talk about helping developers build applications in a way which is serverless, okay? So we'll start off with this State of the Union, which is a quick recap actually of what's new with AWS Lambda and associated services. Obviously we had AWS reInvent at the end of last year. You can see this gentleman down here is wearing one of our reInvent replay t-shirts. So we're just going to recap quickly some of the stuff that we've launched at reInvent and since then. And then we'll move on from this first session to some deeper content, which is more hands-on, demo-orientated, where we're going to show you how to get started with different aspects of the AWS serverless toolkit. Okay, so first up after me is going to be Danilo Pocha. If you don't know Danilo, he is the author of a book called AWS Lambda in Action, which was actually the first commercially published piece of work about building applications using AWS Lambda. It came out last November, so it's about 14 months old, that. Pretty successful. Danilo's the author of that. He's going to be talking, first of all today, about the developer experience for creating applications using AWS Lambda and the rest of the tool set. And then he's going to return at the end of the day for a session on step functions, which is our state machine that enables you to coordinate loosely coupled architectures of different Lambda functions to build more complex apps. So that'll be the last session of the day. In the middle, we'll have some stuff on DynamoDB, which is our state store, our non-relational database that many customers choose to integrate with AWS Lambda. And we'll also have a session on architectural patterns for serverless apps as well. So we're going to tour around all things related to serverless in this room throughout the course of the day. So what is the problem that we're trying to solve here when we think about enabling developers to create applications without running machines, okay, without thinking about these lower level infrastructure building blocks? For anything like me and you've got 20 years in IT, 20 plus years in IT, wow, that's embarrassing. Probably spent the majority of your career thinking about machines, okay? So I want to deploy an app, I need machines for that. We started out with physical, in my case, Sonos 413 systems that looked like pizza boxes that lived in racks, and then Intel architecture machines running Linux. And really our building block was the Compaq or HP, DL, whatever it was, server that would deploy our apps onto, right? As many as we needed in order to make that a reality. Then virtualization arrived, and that was really nice. It was nice for a couple of reasons. First of all, it allowed us to templatize and deploy operating systems much more quickly, almost in an on-demand way, but not quite, so shortening the time to provision these resources. And it also helped us with efficiency, okay? So we could run lots and lots of distinct machines, which were inside their own virtual machine containers, on the same underlying hardware platform. That enabled us to use our hardware in a more efficient way. And it also enabled some availability features, like we could quickly teleport a virtual machine from one physical box to another with certain virtualization platforms. Or we could quickly clone and duplicate large numbers of machines for testing and development or for scaling purposes. So that substrate, as it was automated and virtualized, it introduced some characteristics which made it easier for us to get things done in higher levels of the stack, right? You're all familiar with this idea that we commoditize and automate the platform, and then we can get more done further up the stack. And actually, serverless, AWS Lambda, and these other services that we've created that have similar characteristics, we're continuing to move along that continuum, okay? So we're thinking more about how we can allow developers, how we can allow software builders and architects to focus only on the things that are unique to their particular application or service, okay? And if you consider what's happened with serverless, we're actually going further down the continuum, down this journey that we first took the first steps on when we started with virtualization technology, okay? So here we're pushing up the level of abstraction from the hardware through the operating system into the runtime. Okay, so rather than having to specify a machine type or specify other characteristics about the low-level platform, all we specify is the runtime container within which we want our software to run. Is it Node? Is it Python? Is it Go? Is it .NET Core? Is it Java? Okay, we deploy our package into that in a fixed format, and the underlying platform takes care of these other attributes. It takes care of scaling out n copies of that runtime environment in order to satisfy the level of demand that we have at a particular point in time, whether that's one function, 1,000 functions, or 100,000 functions. The platform will deliver the capacity that we need when we need it on demand, spinning up additional copies of that application with the associated container as we need it. It will deal with high availability in a couple of different ways. First of all, it will distribute those runtime containers across lower level infrastructure primitives. In our case, this is our availability zones. So you can target a particular region within which to run your serverless application. We will take care of ensuring that both the compute part of your app and the state stores and other components like queues or API edges that you might run, they're all distributed across multiple data centers, and they're all managed in a way such that you are, well, not only are you isolated from failures, failures are actually invisible to you. Okay, so if a low-level component like a machine or even an entire data center or availability zone fails, do you notice that if you're using a serverless approach to architecture? No, you don't. That is something which is below the abstraction layer at which you're operating. And those infrastructure building blocks, those infrastructure components, even the large-scale expensive ones like data centers, are hidden away from you as a developer or operator. You don't see them, okay? The next time a copy of your function runs, it'll be running in a different data center which is still available. And if you're using another one of our abstracted services like Dynamo or Kinesis or an SQSQ, we're using the availability zones to deliver the fundamental availability characteristics of that service component. You don't have to think about or worry about that as part of your deployment planning or part of your operations. Okay? So that's high availability. And then on pricing, actually, in the third quarter last year, we changed the way in which pricing works for our Linux-based virtual machines, our EC2 instances. So we now have per second billing for our virtual machine platform for our EC2 instances, as long as you're running on versions of the Linux operating system that qualify for that particular billing model. Okay? But Lambda takes it beyond that. We have 100 millisecond billing increments here. So you're paying on 1/10 of a second units of consumption. Okay, so it's 6 times better, 6 times more granular than EC2, and very much more elastic in the sense that we will scale out to very large amounts of capacity if you need them, and scale in to 0 amounts of capacity if your application is completely idle. And your charging will precisely follow that profile. You'll be metered and billed for exactly what you use in terms of usage on this service. Okay, so a very, very efficient way to run applications, particularly applications that are highly volatile in terms of their usage patterns. Okay, we can talk about a few examples of this later, but there's one example of a gaming operator here in the UK that was using AWS Lambda very early in its lifetime to customize outbound push notifications for a mobile app that they were running. They were delivering 150,000 of these push notifications a second, every single one of them customized for a particular user by merging in data about the user and data about topics that they were interested in this case, Premier League football games, pushing those out to mobile endpoints with customization. The only complexity is that they were only doing this for about a 10-minute period on a Saturday afternoon, or only doing it at this level of volume for about 10 minutes on a Saturday afternoon. So they could scale their app up to this massive level of capacity, push out huge numbers of these push notifications to drive engagement with the applications that they were running, drive engagements with the services that they were running, and then immediately after that tsunami of demand had vanished, all of their capacity would be taken away, and they would just pay for that usage peak for those 2 spikes at the end of the first half and at the end of the second half of Premier League games every weekend. So a really good tangible example of how customers put this elasticity, put this very, very discrete billing model to use for a specific application type. Okay, so let's take a look at some of the recent enhancements we've made to the AWS serverless platform. And the first thing is thinking about this in the context of developer workflows. So let's just say that you're asked to create an application that delivers the ability for customers to modify a profile for an app. Okay, so typically we would build this by creating a web or mobile application using a shared API backend to enable us to share those business logic components across the different application platforms that we want to use. Okay, so maybe we've got React Mobile, maybe we've got a web app, we want to build the backend once. Want to use a state store that enables customers to store JSON documents that contain information about their profile and settings. We want to do this in a way which is serverless, so we have a high degree of elasticity. We don't have to think about scaling this application in response to demand or scaling it down in response to periods of slack demand. And we want to encode our business logic as Lambda functions. How do we get started with that? At AWS reInvent, we announced a new component for the AWS serverless portfolio called the Serverless Application Repository. Okay, this is in preview at the moment. All familiar with the difference between private preview, preview, and beta? Or shall I just dig into that quickly? So private preview, we invite you to participate essentially. So there are services that AWS is developing, experimenting with right now, and there are customers using those services. And unless you are working for one of those customers, you don't know about that those services exist. Okay, so we have them under NDA. Actually, a lot of examples of this right now, where we are experimenting with groups of early adopters to help us refine use cases, help us refine console experiences, help us refine service offerings, even pricing plans and business models for new services that we're thinking about. But if we haven't invited you to participate, you wouldn't know about them. Okay, so that's a private preview. A public preview, which is the state that this service is in, it means we've announced the service, okay? We have asked customers to participate in the preview, but it is a gated sign-up. Okay, so to access the preview, you come to our website, the product detail page typically, you register for the preview, we qualify your use case, and then we gate you into the preview by whitelisting you, activating you to use that particular service. Once you're whitelisted, and the process of whitelisting requires your AWS account number, then you can see modifications in our console. You can access the API endpoints associated with that particular service, often by downloading custom model files that are used with our CLI or SDKs. Okay? This is an example of a console screenshot from an account that's been whitelisted for this serverless application repository, which is a new service that we have in public preview right now. This is my AWS account, actually an AWS account of a colleague, and you can see that I've got a panel here which shows the serverless application repository. This is in the Lambda create function page within the AWS Lambda console. Okay, so if you're not whitelisted, you're still going to have these two things, author from scratch and blueprints, but you're not going to see this box. Okay, and this box exposes new functionality for customers that allows them to access a library or marketplace of prepackaged applications that have been created by other developers. Okay, created by other developers and uploaded into the serverless application repository as templates or full-blown applications that other AWS customers can choose to use. Okay, when you choose to use one, you are going to be deploying one of these template applications into your AWS account. So you're going to be creating resources within your AWS account that are defined within the serverless application template, which is defined using our SAM, serverless application model templating language, from this repository. Okay, you can search the repository, you can see the popularity of applications and templates that have been deposited there by other developers, and you can also see their authorship, okay, so establish who's created them. As a developer, you can also create your own application templates using SAM, and you can upload those into the serverless application repository. We take them through a short qualification process, and then other developers will be able to make use of your applications inside their AWS accounts. So it's a little bit like Amazon Machine Images or ARMIs for virtual machines, which a lot of you will be familiar with. You can share those across accounts, but it's for a different type of abstraction. The type of abstraction that it's for, of course, is the serverless app, and the abstraction model that's used is these SAM templates that I've talked about a second ago. Okay? And these SAM templates are YAML files using a defined syntax, of course. They can benefit from things like expansion tokens. So when another AWS customer chooses to deploy an application from the serverless application repository, it gets customized for their account. Okay, so we're going to do token expansion here, create things like custom S3 buckets, custom Kinesis streams potentially, other types of resource, and those will be specific for that instance of the application created within the target account, within the user's account. Okay, so you can modify the apps using this template-driven approach. So why would we have this? Well, it enables you to share and browse ready-made applications and samples. Okay? It enables you to do that publicly, so I can open up an application for general use by any other AWS customer. It also enables me to do it privately. So if I'm working in an organization where I've got, say, several different independent teams that are working on creating services that we want to share within our company, or even within our company and with selected third-party customers or partners, we can create applications within this serverless application repository, and then we can whitelist specific target accounts ourselves and make those applications visible only to those specific accounts. Okay, so I could use this within an enterprise, within a customer organization, to create my own reusable library of serverless components that other development teams inside my own organization could then reuse in a trusted way. So it's a distribution model that I can use in that way. Today, it's not possible to directly monetize applications within the repository, okay, but it is possible to point applications within the repository, of course, at commercial API endpoints. Okay, so if I was providing, say, a payment services API or a geospatial data API or some sort of data analytics or even AI or ML API, I could hard code those API endpoints inside my application templates, and I could require registration and establish a monetization boundary at those API endpoints that are consumed by my serverless apps. So I can use this as a mechanism for delivering serverless SDKs, essentially, that enable my customers to use services that I do choose to charge for within my own business model. Okay, so we have that. And within our AWS marketplace, we have a mechanism for charging, metering, and managing subscriptions to API endpoints. So you can actually manage all that within the AWS marketplace environment, allowing your customers to sign up for your APIs, bill via their existing AWS account relationships, and then we pay you for that consumption. Okay? If you're interested in doing that, you should talk to us, okay? Because we have a partner program for API providers that want to do that, or you could use your own alternative sign-up and authorization and authentication mechanism equally, okay? And then we have, of course, this SAM model, which is actually a derivative of AWS CloudFormation using YAML, as I've already mentioned, that enables you to define applications in this way, using both a simplified notation for commonly used serverless resources, which you'll hear more about in the second session of the day, or full-blown CloudFormation if you want to use full-blown AWS resources like IAM roles, Kinesis streams, and some of these higher order services that are not currently supported by SAM. SAM is open source. You can find the definitions that are used for that model on the AWS GitHub account. Okay, so that's serverless application repository. The second new thing that we announced at AWS reInvent was a set of enhancements to the AWS Lambda console. Okay, so probably familiar with the Lambda console. Since launch, you've been able to edit handlers in there. When I talk about a handler, I'm talking about the entry point that the runtime invokes when a function is initiated. Okay, it's typically one file of JavaScript, Python. We now support C#, which we'll talk about a little bit later. We now support Go, and we also support Java. But typically, customers have used the editor within the console to edit the interpreted languages, and to do that with simple functions that do not have dependencies. Okay, so there was a variation in the deployment model for simple functions which didn't have dependencies, or for deployment packages where you needed to include dependencies within the deployment package. For the second option, you would create a zip file as part of your pipeline or on your workstation, and then push that into the AWS Lambda API, or upload it to Amazon S3 and reference it. And then Lambda would grab that and establish it within your account as the container basis that would be used when that function was invoked. With this new editor, we've removed the limitation on editing multi-file packages. Okay, so you can see and edit the complete file hierarchy that is included within your deployable directly within the console. You can also add new dependencies and modify existing dependencies directly within this editor. Okay. You can also run tests and view results and logs for interpreted languages directly within the editor, and you have this WYSIWYG What you see is what you get, designer for authoring functions as well. So it's a real improvement to the developer experience directly within the Lambda console. You're going to see a lot more of that in the second session after the break this morning, where Danilo will demo the new editor functionality that we have there.
Briefly explain what's missing.
It means that you can see the dependencies that your function has. So for example, if my function has IAM roles associated with it, which grant the permission to access other AWS service endpoints, those are visible visually within the function. I can see the IAM roles associated with the function. I can see the service icons for the AWS services that function is authorized to call, and I can directly drill into things like the IAM policies from within the console. Okay, so you get a visual display of what the trust relationships are between that function and other AWS services. It's actually really helpful for operating under a principle of least privilege. You know, you could look at a function and think, oh, why have I got access to X or Y if it's not required in my code? And then scrunch down, close down your security policies as a result of that visual display. That's the main way that I use it. Yeah. You can also attach new policies directly within the console as well. Okay, so that's the function editor, and Danilo will show you this after the break. The other thing we've done is work on quite a few developer quality of life enhancements to improve the breadth of use cases that Lambda can be applied to, and fix some common hurdles really, or allow developers to overcome some common hurdles to using AWS Lambda more easily. Okay, so the first thing is we have increased the number of concurrent executions to 1,000 concurrent executions per account per region by default. Okay, it used to be 100. So this means that you can have 1,000 concurrent copies of your functions in aggregate running in any region without having to ask for what we call a limit increase, or in fact contact AWS in any way. So that is the new default that all accounts benefit from. And that really converts to about 10,000 transactions per second if you've got 100 millisecond or less execution time, of course. Okay. We also have auto approval to 3 times the default, automatically on request. So if you do raise a limit request and you say, I want to go up to 3,000 concurrent function executions per region, as long as your account has what we call a good containment score, in other words, there's nothing there that indicates that the account is a risk in any way, we will automatically approve you for 3,000 concurrent executions per region. Okay? And as I've already mentioned, many customers have much higher limits than that. About 6 months after launch, I was aware of this one customer that had 125,000 concurrent executions per region, which is 1.2 million times the old default. Okay, so we can go big in terms of giving you lots and lots of execution capacity. So why do you think these limits are there? You know, why do you think, if we can go so big, why do you think we have limits of 1,000 concurrent or 3,000 automatic approval? The answer is to protect you, to protect customers from excessive spend. So we'd recommend tuning these limits in a way which gates your AWS bill, constrains your AWS bill. If you've got an expected level of usage, then try to set your limits just a little bit above that expected level of usage. If you do get, say, a distributed denial of service attack against one of your endpoints, or you somehow introduce a bug in your code which drives much higher than anticipated levels of usage, you'll get throttled. Okay? You'll see that in your CloudWatch metrics, and you'll prevent yourselves from having a large billing overrun as a result of excessive usage. So you should tune these limits in a way which is consistent with your anticipated level of usage. They're there not to really protect us, they're more there to protect you and ensure that you're operating in a way which is cost optimal. Okay? So use them. We've got some other enhancements that we've made as well. And if you do need to go extremely wide and have real mass scale concurrent function execution, again, you should chat with us. Okay, we can help you with a few things. Firstly, with the limit increase, of course. But secondly, with offering guidance about how you might optimize your application to reduce costs, or do real-world performance testing through load injection to ensure that your function performs in the way you anticipate once you start to drive really significant load through it. Okay, so your functions are unlikely to exist in isolation. It's probable that you've got a state store behind them, or a queue behind them. So let us help you assess your architecture and make sure that when you turn up this dial at the front end, you're not going to cause issues as you get into the dependencies within your app. Let us help you, let us review your architecture with you, and make sure that you're making the best and most efficient use of AWS that you can for cost optimization and for performance, of course. We've got lots of experience with helping customers do this stuff at scale. The other thing we've done is work on cold start optimization. Now, there's a bit of internals here. So what do you think actually happens when my Lambda function gets invoked if I haven't run it for a while? Okay. Lambda functions are packaged up in containers, okay? And those containers have to be deployed down onto, CPUs, because believe it or not, within serverless, there are actually CPUs involved. There is memory bandwidth, there are memory controllers, there are solid-state disks, there are machines there, okay? It's just you don't have to worry about them, okay? But we still need to get the container from its storage location within AWS down onto that CPU so it can start to be executed, right? We also need to wire in the programmable networking platform and deliver traffic to and from that endpoint. Otherwise, it will execute in isolation. You'll never get the results back to your API request. You'll never process that object in that data stream or respond to that event, right? So that results in what we call a cold start the first time the container is deployed onto that machine. And then subsequent executions, well, it's cached, okay? And that machine will get hit by the next event and the next event and the next event, potentially running multiple copies of the same container until we exhaust the resources of the VM which is hosting that particular function, that particular container. And then what happens? We need another machine for more budget. So we pull down another container. Somewhere in your metrics, you'll see one more function start, which is a cold start, which has a higher degree of latency, okay? And then that machine's warm, and that's getting used. And then maybe we get a third, fourth, fifth, and sixth machine. And each time we bring one of these machines into the service, you get one function start, which is slightly slower than all of the others, okay, because that is a cold start. We've done work here to optimize that, particularly for larger functions. So less of an issue for simple functions where you have either small statically compiled binaries with things like Golang functions or small scripts in Python or JavaScript, which are obviously interpreted on the machine. All you're pushing down is the source, essentially, for interpreter execution. With large bytecode, so Java functions predominantly that are really big, okay, can be really big if you've got a lot of dependencies built into them. You've got a large container to move across the network, and that's where this 80% reduction in function start time comes in. We've taken steps to optimize the way in which we get the containers from the container registries that we run down onto the execution machines to minimize that cold start time for larger functions. That was something that a few customers suggested we focus on in order to improve efficiency. Third thing we've done is changed the Lambda console to make it easier to surface and access execution logs for your functions. So we have integration here with something called CloudWatch Logs, which allows us to collect log streams from the Lambda functions that are executing, store those in a central location in a durable way, and enable you to search them, even enable you to create metrics on top of those logs if you wish to do so. And what we have done is integrate the experience for accessing those logs directly within the console. So I can look at my functions in the Lambda console, click a button, and immediately see all of the log streams associated with that function. So it's a quality of life improvement, really, that just makes it easier for you to access your logging data. Very helpful if you're a bad Python programmer like me and you have a lot of debugging to do. Okay, come to my session later on Amazon Lex and see exactly how bad I am. Okay, that's all I'll say. Memory size. This is another very important attribute of AWS Lambda that is sometimes, I think, not as well understood as it could be. So when we talk about memory allocation, okay, we're not just talking about memory allocation. We talk about memory allocation for functions. You can replace memory with resource allocation, okay? The dial that you turn is RAM, okay, from 128 megs up to 3 gigs now, because we've doubled the top limit on that. But you're actually allocating not only RAM, you're actually allocating machine shares, okay? And when you allocate machine shares, you're giving RAM, CPU, and network bandwidth to that function in proportion. They all scale linearly in accordance with the amount of memory that you give. So a 128 megabyte function, turn it up to 1.28 gigs, you're giving 10 times the amount of CPU performance and 10 times the amount of network performance and 10 times the amount of sockets, TCP sockets, for that function as well. Okay, so if you've got a function which is resource constrained, not just on memory but on CPU or I/O or network performance, you can increase all of those things by turning up the amount of memory that you allocate. Okay, so if you've got a function that is CPU intensive, give it more memory, it will get more CPU and it will perform more quickly, even if it doesn't need all of the memory budget. This is just the lever that you pull, but when you pull a lever, it's just the make it bigger or make it smaller lever that you're pulling, and all resources will scale in accordance with that memory budget allocation. Okay, by turning up the maximum from 1.5 to 3 gigs, what we're doing actually is saying, are we allowing your functions to have twice as much CPU and twice as much memory performance, as well as twice as much network performance, as well as twice as much memory. Okay. And then brand new, this is 15th of January, we made these two new runtimes available, so just 3 weeks ago. .NET Core 2.0, so C# and .NET Core 2.0 runtime, that's available now, and support for Golang as well, so you can run your lightweight, statically compiled, normally high-performance Go on AWS Lambda as well. And over here, we also integrated something called SAM Local, which enables you to run many components of the AWS serverless platform on a developer laptop, your local machine, independent of the cloud. We also integrated Golang runtime into that. And we created some templates in another service we have called AWS CodeStar for continuous integration for Golang as well. And we also shipped a beta SDK for another service that we have called AWS X-Ray, which is an instrumentation and tracing service that enables you to provide distributed visibility into distributed applications using a small SDK that you embed into your Lambda functions. Okay, so we also have support for Go in AWS X-Ray as well. Okay, that all came out on the same day, on the 15th. And most of it was developed by Paul Maddox, who is next door right now talking about containers, one of our solutions architects, specializing in DevOps and serverless. Okay, so that's all about these quality of life improvements. The other thing that we have worked on is in the wraparound, if you like, the CI/CD tooling, the IDE toolchain, the deployment capabilities that make it safer to use AWS Lambda inside production apps. Okay, so this has been a big area of focus for customers. We were lacking, at first launch a couple of years ago, we were lacking some of these, lacking support for some of these requirements that customers really need in order to run AWS Lambda in production. Okay, so some of the things we've done on this side of things. First of all, we announced a new service at reInvent called AWS Cloud9. Okay, this is a company we acquired a couple of years ago. It used to be called Cloud9. We've rebranded it. This provides a cloud-based IDE. Okay, so you can establish an integrated development environment that runs inside your browser with an editor, with a debugger, with the ability to invoke a console session, a terminal session, and inside there is Lambda Blueprint support for SAM Local, which I just mentioned a minute ago. So that's the idea that you can run a serverless development environment on your developer laptop or workstation. Well, you can also run that same serverless developer environment in the cloud, integrated into the Cloud9 IDE. Okay? That provides a testing harness. It provides a local runtime environment for our API gateway for AWS Lambda, and it provides an emulator for DynamoDB as well. So you can run a complete serverless environment as you would define it using SAM, the serverless application model, natively within the IDE, within Cloud9 IDE, or natively directly on your laptop. And on your laptop, obviously, you can do that in disconnected mode as well. Okay, so you can build and test serverless apps without being connected to the cloud or to the internet, for that matter. Okay, so pretty useful for developers that might be working mobilely. With this Cloud9 IDE, you can deploy directly to Lambda You can also, of course, integrate with Git-based source control systems, Git-compatible source control systems, to enable you to take your code out of the IDE, push it to Git, and then pull it down onto a developer laptop. So you can move code out of the IDE into mobile developer environments if you need it. And we have IDE debugging for Lambda functions. So for JavaScript functions, you can set breakpoints, do step-based execution, inspect variables and other aspects of program state natively within the IDE. So you can connect a debugger to a container, which is running your Lambda function within the SAM local environment, again, which has been one of the things that developers have asked for since we created this service back in 2015. Okay? So tidying up, enhancing the developer experience, which Danilo will show you in the next session in more detail. And then deployment. So you can deploy to AWS Lambda using another service we have called Code Pipeline. This is a service for a managed service for establishing build pipelines natively within AWS. So commit to source code repositories, GitHub or our own code commit service, build Lambda deployment packages using dependency management with requirements.txt or with node modules or with bytecode compilation steps for Java. Establish your deployment package, that zip file I was talking about earlier, and potentially encompass other CloudFormation resources in that deployment package, and then push all of that to CloudFormation or directly to deployment into AWS Lambda via AWS Code Deploy, which is our deployment service. Now, the cool thing about this is it's wrapped up in another service that I mentioned earlier called CodeStar, and you can literally establish that whole build pipeline in like 5 clicks within the AWS console, which will create you a source code repository with a template application in it, establish the build automation and the deployment automation for you, and create the template function as a first deployment target. You can then modify your code, check it into the source code repository, and whatever commit you make will end up reflected in AWS Lambda in just a couple of minutes. It is so easy to use. As a developer getting started with AWS for creating applications, I can't really imagine why you'd do it any other way. Okay? We support GitHub at the beginning as well as code commit, so you can also develop applications in the open using the same kind of pipeline with a web-based commit and branch management tool if you want, or you can use our code commit service, which has some advantages in terms of security and compliance for customers that might be operating in regulated or highly secure environments, okay, because it benefits from things like our ISO 27001 and PCI DSS compliance statements. And for certain types of developers, that's obviously very, very important. But you can also use GitHub if that's your preferred model. If you've not used CodeStar, I mean, if you've got one takeaway from this whole track today, okay, I would say go and try deploying a serverless application using this tool. It is so easy. I just don't understand why you would do it any other way. And your first pipeline is in the free tier as well, so it will cost you nothing to experiment with it. It's a really, really good tool. Now, on deployment specifically, what I've described, of course, is pretty simple, okay? So that is putting an application into production use or test use for the first time. It's about as simple as it gets, okay? But of course, once you've got live customers using an application or service, or you've got product managers driving feature enhancements on an application or service, potentially with several different ideas in mind at the same time, things are quite a bit more complicated than the simplistic use case that I've just talked about, right? You've got a few more things to consider. And this is something else that we've been doing a lot of work on. How do we make it safer and easier for customers to use good software deployment practices in conjunction with serverless apps? Okay, we've been doing a lot of work on this. So first thing that we announced at AWS reInvent is something called weighted aliases. And this literally allows me to have 2 variants or more than 2 variants of an AWS Lambda function in production at the same time. Okay? And to distribute traffic across those 2 or more variants in accordance with a weighted algorithm. So put 95% on the production version and 5% on this new experimental version that I have. Okay, now you've always been able to do that if your functions have been behind an API gateway. Okay? And in order to do that behind an API gateway, you would have 2 API endpoints, okay? And you would use DNS load balancing to distribute traffic with weightings across those two endpoints. What do we know about DNS load balancing? It's not an exact science, is it? Because DNS resolution requests get cached, okay? So some clients will end up pinned on a beta version of your endpoint, even if you don't want them to be. And it's actually hard to retire the beta version of the endpoint once a client has it in their DNS cache. So it's a fine-grained but difficult to control mechanism for distributing traffic, right? Agree? You all know about this problem. With this model, we remove that. So you can have one API gateway or one other event source, maybe an IoT event source or a Kinesis stream or an event source that comes from something like a Lex chatbot, which is also driving invocation of Lambda functions. And we're managing the weighted execution directly in the Lambda function invocation stream, directly in the invocation path. Okay? So we can then execute fine-grained control. We can introduce or eliminate versions of the function much, much more rapidly and have a much higher degree of control over their introduction and removal from the weighted set. Okay, so this is a really useful feature for customers that want to test multiple versions of a function. Also, in order to help customers that wanted to continue to use API Gateway, we've removed the requirement to have multiple DNS records. So you can share within the API gateway as well across different substages. Okay, so to smoothly migrate traffic between two versions of an API or to have two different versions of an API in production at the same time for A/B testing. Okay, so we've also got that as an additional control point. And then with Code Deploy, which is our deployment service that fits into that pipeline that I talked about earlier, we can do smooth weighted deployments with metrics-driven rollback. Okay, so what this means is we can establish a deployment. We can start to shift traffic between two different versions of an AWS Lambda function as part of this deployment process, which you can see here, gradually moving the traffic between them. We can use metrics to health check to establish whether that deployment is being successful. And if we start to see elevated error rates during that deployment, we can automatically roll back and remove that deployment on the basis of metrics. Okay, so it's helping us minimize the amount of overhead associated with our deployment activities and helping our dev teams be more autonomous and require less operations support in a lot of cases to get their code out into production. Okay, even allowing things like out-of-hours deployments with automated rollback on the basis of metrics. So that's a pretty useful feature. And then we also have this weighted functionality that I talked about earlier for Canary deployments. This is showing a Canary deployment in API Gateway. You can see here that we're directing 10% of our traffic, of our requests to that Canary deployment, and 90% of it goes onto our old prod stage, which is our tried and trusted version of our API. And then we can observe directly within the CloudWatch metrics console how our traffic is being distributed across the two different variants that we have. Here you can see that we've got 1.2K requests per second hitting prod and 113 hitting our prod/canary stage endpoint. Okay, so that's about 10% of our load. Okay, so we've got fine-grained control there. Within the console, we can update that within real time, reapportion traffic between the production version and the new version that we've got in testing in near real time as well. Okay, so really helpful features, I think, for developers that want to manage incremental deployment, experimentation, testing of serverless applications in a more robust, in a safer way. I'd characterize it as safer deployments, really. Okay, 10 minutes left. So let's talk now about some stuff that we've done for enterprise customers. So one of the other things we've heard about is, AWS Lambda, great for, cloud native where everything's simple. We're always building new things, or we have no connectivity back to legacy systems. That is typically something that's more complex, more difficult to manage. But what about if we want to integrate a serverless app with something we already have, and that something we already have has, traditional enterprise characteristics. In other words, we're working with fixed licensing pools. It's expensive, difficult to change, yada, yada, yada. Okay, so how do we deal with that? There's a few things we've done here, okay? So concurrency monitoring, concurrency limits, okay? Establishing integration between services that are running on AWS Lambda and other serverless components but need to communicate and talk to services that are within the VPC security perimeter. Okay, so that's something I'm going to talk about as well. And then lastly, logging and auditing, okay, for customers that are operating in either compliant environments or customers that have a requirement for something called protective monitoring. If you've heard those two words before together in combination, you'll know what I'm talking about, which is a particular set of security practices that are used in the UK public sector. Okay? So, what have we done here? Okay. First thing is providing a mechanism for, providing a mechanism for customers to control concurrency of Lambda functions. Okay. Creating a mechanism to quickly retire functions that are behaving badly. Okay. And providing a mechanism for gating or limiting concurrency in order to manage throughput. So what we really heard was that concurrency control is really important to this particular class of customers. Okay, so in order to help address that, we've introduced a couple of new things. The first is a concurrency metric. So you can look at each of your functions and see in the CloudWatch metrics console what their level of concurrency is. So how many copies of function A are being run, how many of B, and how many of C, in comparison to before, which would be your total number of concurrent invocations across all functions in a region. So it's more granular reporting about concurrency to enable developers to take more informed decisions about how they manage it. Okay? And then obviously going beyond that, once you've got the visibility, well, you can use those same metrics to establish some controls. You know, say that function A is allowed 100 concurrent executions and no more than that because we only have 100 licenses to connect back to our backend relational databases. 100 concurrent connections. Okay, so we can do that as well, and we can do that on a per function basis. This allows us to limit concurrency to legacy systems. It allows us to protect production services from other functions in the same account. So say we've got one Lambda function that is related to charging customers for a product and another which is used for reporting. Don't we want to prioritize the one that actually generates us revenue? So that if somebody misbehaves in writing a query on one of our reporting systems, we don't end up diminishing our ability to sell a product or to charge a customer. This allows us to do that. It allows us to say, right, this particular function is going to be capped in terms of its concurrency level, and this other function is not. So we'll never use more than, say, 10% of our capacity for our MI API, okay, leaving 90% of our capacity available for the functions that actually serve our customers. So we can implement some business rules by using these concurrency controls. We can also use this as a mechanism to very quickly disable a function just by setting its concurrency level to 0, okay, without having to deprovision it or delete it. Essentially switch it off by flicking a switch. Very, very responsive. Only takes a second to issue an API call like that or to change a value in the console, and we're just going to remove that function from service. Okay. And last week, we can also use this as an additional protection, as I mentioned earlier, where you might use your overall account limit as a mechanism to prevent billing overruns or control concurrency. You can do exactly the same thing at the individual function level by using this tool. And then on connectivity, for quite a while now, we've had the ability to run Lambda functions with ENIs, or elastic network interfaces, attached to them. This essentially allows your Lambda function to run inside your VPC, okay, to access VPC-based resources. So it has both an ENI and a security group associated with it. You could use this to integrate Lambda functions with things like RDS, or even with non-relational databases other than DynamoDB that don't support IAM roles and request signing. Okay? I did a demo quite a while ago of integrating AWS Lambda with MongoDB using exactly the same model. Lambda functions run on a specific subnet inside the VPC. They have a specific security group associated with them. The MongoDB or relational database endpoint permits traffic from that security group, and magically your Lambda functions can communicate with your relational and non-relational state store within the perimeter of your VPC without having to send traffic out onto the internet. So they can run privately in that context. It's a really nice use case. With this new service, VPC Private Link, you can do more than that, okay? You can both expose services and data within your VPC from a public API endpoint. Okay, so the public API endpoint is out on the internet, and then private link is used to wire from that API endpoint directly to within your VPC. So that's a nice feature. And secondly, partners can use private link to offer API or other service endpoints to other AWS accounts. Okay, so say I've got a private API, maybe I've got an API which is used only by finance customers, and therefore I know implicitly that because of the regulatory nature of the data behind that API, it can't be put out on the internet. Okay, but I do have a large constituency of customers within AWS that want to use it. I can offer up that API endpoint as a private link service. Other AWS accounts can subscribe to it, and they'll see it appear within their VPC as an endpoint directly within a specific VPC that they specify. It's not available publicly. It will never be available publicly, but I can offer it up to nominated AWS accounts on a whitelisting basis. So this concept of whitelisting is becoming increasingly important. Okay. Also with the API gateway, we introduced another enhancement, which is a region-specific endpoint. So we used to have the API gateway available only on our edge network. It's in over 100 locations around the world, but it's only on the edge network. Now you can also restrict the Amazon API gateway service to a specific nominated regional endpoint. Okay, so some enhancements for regulatory control. Probably you can appreciate how that second feature could be important with things like GDPR, where you might need to keep data associated with a specific service in a specific regional location. Okay, and with the potential implications of Brexit from a regulatory perspective, there's another use case there where you might want data in the UK, data in Ireland, and you can separate your APIs and deploy them in specific regions to meet future regulatory requirements as well. Quite important. Okay, this is how you provision that. I'll just jump over this. And then lastly, I talked about all that, didn't I? Lastly, log and audit. Okay, so structured logging for APIs. This is about how we store information about API endpoint requests within CloudWatch logs. Okay, so we've got a structured logging capability there now. It makes it easier for you to search and organize logging data about API endpoint requests. We've also added AWS CloudTrail support for Lambda functions. If you're not familiar with AWS CloudTrail, this is a API auditing service that allows you to establish a continuous log of all requests that hit all requests that hit AWS API endpoints using identities associated with your account. Okay, so you can use it for observability and this kind of protected monitoring that I talked about earlier. It will literally record everything. Okay, so take my Lambda function use case as an example. Each time I invoke a Lambda function, I'll end up with an entry in my CloudTrail log. I can see the credentials that were used to invoke that function, the originating IP address, the timestamp, of course, and the query parameters that came in with the request. Okay, I can then interrogate, search, filter, alert upon that data using patterns that I define or third-party tools that I might choose to deploy. Okay, so it gives me observability over the usage of the APIs that I'm defining, and not only if they are exposed via an API gateway, but also if they're exposed directly for invocation with AWS access and secret keys. Okay, so fine-grained visibility over usage of my services. Okay, so what have we done on the enterprise? Basically, what we're trying to do here is address some of the inhibitors that enterprise customers have told us are important to their usage of this serverless technology in conjunction with legacy systems and in conjunction with the governance and control frameworks that are present inside these regulated and more complex environments. Okay, so trying to make it easier for customers of that type to use AWS Lambda and associated services. Okay, so that concludes this quick recap of what's new with AWS Lambda and serverless more generally on AWS. Got 2 minutes. Does anybody have any questions they want to ask? Yeah.
Yeah, I noticed on the pipeline slide there was a gap in testing.
Okay.
What's the best practices?
Yep. So the question here is about how we support testing inside our code pipeline. The answer is that we have a partner ecosystem that plug in there. So we don't have our own suite of integration or functional testing tools. Okay, we do partner with companies like RunScope, HPE, and a variety of others. If you go to the aws.amazon.com/code pipelines page, okay, you will find a lot of information about testing partners that are supported. In running these pipelines, you have configurable stages, okay? So you can write your own routines as well that are invoked, your own code that is invoked when the pipeline reaches a certain point, okay? And those themselves can actually be Lambda functions. So that's how some of these partners integrate, and there are also other integration methods as well. But essentially, testing is today provided by this group of partners that we work with. And you can then have stop-go conditions, branching in the pipeline, even multi-environment deployments within a pipeline as well. So you can push a release candidate into a beta environment, for example, run testing against that, and then have an automated or manual step to continue that pipeline to push that beta candidate out into a production deployment. There's a lot of configurability within the pipelines. We establish simple pipelines with CodeStar, but you're then free to modify them as you see fit. Okay? Any other questions? Yeah.
We have problems in the past with code build, accessing external resources, like Nexus for dependencies.
Yep.
Has anything been done in terms of adapting that to have access to the VPC?
Could build access for VPC. I'm not sure about that. I need to check it, so I'd need to take a look at the docs. Maybe we can cover it offline afterwards. Certainly works for external dependencies, so pulling from public repos. I'm not sure about VPC access. It's difficult because I have the roadmap, and I'll be careful I don't say something which is on the roadmap, so I'm going to check that. Okay. There was a question here, yeah?
Yeah, is there any carryover duplication between the canary builds that you have in API gateway?
So is there overlap between the canary builds within the API gateway and code pipeline? There's several different approaches that you can take here, okay? As is the case with many AWS services, there's like more than one tool that you can use for the job. Within code pipeline, you could establish a custom pipeline that deployed a release candidate to a different endpoint if you wished, okay? Or you could establish a pipeline that modified an existing endpoint to create a canary deployment, okay? So you could do it either way, depending on how you configure your automation within the pipeline, essentially. Or you could do it manually in the console for a particular manually driven change. So you can do it whichever way you wish, really. There was one more question over here, and then we're probably out of time.
Yeah. We use the Node CLI serverless.
Yes?
AWS involved in that tool, or things like SAM, are they your alternative?
I wouldn't say that they're necessarily an alternative. They are different approaches for solving the same kind of problem. I know that the serverless framework is incredibly popular, and I know a lot of customers that use it, and we certainly regard it as a valuable tool for customers to use. With SAM, one of the things that you can do, which I'm not an expert on serverless, so I might be wrong here, but one of the things that I like about SAM is that you can blend these simplified resources together with full-blown CloudFormation template content. So if you've got an application which includes resources that are serverless plus resources that are a little bit less serverless, like say an RDS database or an Elasticsearch cluster, for example, with SAM, you can blend those things into a single template file or a collection of template files and manage it all in a cohesive way. I don't believe that that is possible with the serverless framework. I think it only supports those specific serverless resource types. Okay, so you've got a little bit more flexibility with SAM, but serverless is still a great tool and a lot of customers use it. Okay, we're out of time. If you've got further more detailed questions, if you didn't see it at the back end of this expo and coffee area here, there's something called the Ask an Architect booth. If you go there, you'll find a gaggle of AWS solutions architects waiting to answer questions. So if there's anything else you want to ask, go there and seek out one of those ladies or men. Thank you.